This is the code presentation for group 2, attribute selection in decision trees. So we have 3 files for this project, code file, data file, and the README. So we'll start with the README. This file explains some background on how to run the code. So we can see that this code demonstrates the ID3 method for attribute selection and generating a decision tree. We're going to use the standard tennis training data set, which was originally presented by Quinlan in Introduction to Decision Trees. This data set is commonly used for demonstrating decision tree operations, and it illustrates the concepts very clearly. This code is a demo, so it works with a supplied data file. For a more flexible version, there are some hard-coded values that could be easily modified to make other data sets work with this, and that's noted in the code itself. We have some version information and dependencies, so we're going to use pandas for data frame operations, as well as a handful of standard libraries for additional functionality. And then we have instructions for running the code itself. We also have the tennis data itself, so that's the data set referenced in the README. So we have days, which identify the observations. We have attributes like outlook, was it sunny, rainy, temperature, humidity, and so forth. And finally, the class data. So the play field gives us the values yes, no, whether the game was played. And then finally, we have the code itself. So let's take a look at that real quick. So we're actually going to start with a main method. So this handles the running of the code itself. We're going to read in a file. So again, for demo purposes, we're expecting this test file that's supplied, but we could easily modify some of these hard-coded values to be a little more flexible if this was meant for a wider range of use cases. So we're going to take in the data, load our pandas data frame, and then kick off the process to generate the tree. And finally, we're going to display the tree output. So we have a class definition. This is going to be for storing nodes. So each node instance will have a label and a category, which correspond to the node value and the decision for that node. And we're also going to store a list of child nodes that will be used for building the tree and later for iterating over the tree. We also have some supporting functions, so we need to generate the tree itself. So we'll start there. So we're going to build the tree using the attribute selection process maximum information gain. So that's the metric that we'll use for selecting attribute. And we're also going to determine when leaf nodes have been reached. And for the cases where there are additional child nodes, we're going to use a recursive function call and work our way down the tree. Then when we're done, we want to be able to iterate over the tree and print the results. So this function follows the nodes. It prints the tree by using level as an indentation multiplier. So we'll actually see how that kind of makes the spacing, keep all the levels even in the output. And the final decision nodes are presented using an arrow to show whether the path terminates with a yes or no decision. So we'll see what that looks like in just a moment. We also need to perform our attribute selection. So we're going to use the information gain metric. So we need to calculate that and then figure out which attribute has the maximum information gain. And in order to calculate that, we also need to know about entropy. So we have get entropy, which is going to calculate the entropy value that is used in attribute selection. All right, so according to the README, we can execute this application, Python id3demo.py, and then a path to the file that contains the data. So if we run that, we get this nice, simple graphical depiction of the resulting decision tree. So we can see that outlook is the attribute that is being selected. We have three possibilities at the next level: sunny, overcast, and rain. Some of these have secondary attribute paths. And finally, the branches terminate with the decision yes or no for each set of attribute conditions.